Welcome to Carlton's Math Corner. Today we're going to be learning about real numbers. And before we begin, I would like for you to look at something that hopefully makes you smile because learning is fun and I want you to be passionate about learning and have a positive attitude. Before we begin, I would like to make sure that you have out your math journal as well as your vocabulary packet. Now your math journal is for you to record examples, any tables, graphs. It could be, word problems, whatever it is that will help you to learn the new concepts. And, make sure that it's organized so that you can look back on it for when you're working on assignments, when you're studying for quizzes or tests. And then your vocabulary packet is for you to record vocabulary terms as well as their definitions and a sketch. And a sketch is basically just an example of the concept. Now in your vocabulary packet, I tried to include every vocab term that I could think of for the year, and it's in alphabetical order. If for some reason I missed a term, please let me know. And I put some blank pages at the end of your packet so that you can add those terms. Today, we are going to be working with classifying real numbers. Now, real numbers is not in your vocab packet because this is a term that we are just introducing. Next year in 7th grade, you will be working with real numbers extensively. This year, though, we are going to focus on a category that's underneath real numbers, and that category is called rational numbers. And so let's talk about, first of all, as an introduction, a real number is basically every number that you have learned so far in your life. So since the moment you can count, it's every number that you have worked with. And so it includes all fractions, decimals, integers, and we'll talk about what those are, and whole numbers. And within that category, there are two categories. And the first one is rational numbers, and then the second one includes irrational numbers. Our entire year is going to be focused on rational numbers. So everything we learn is going to be including all of these all of these numbers. And rational numbers are basically any number that we can write as a fraction. So for instance, whole numbers. Well, whole numbers I can write as a fraction because they are like counting numbers and they include 0. And I can write them as a fraction because I can even just put a 1 underneath them. And 8 divided by 1, or 8/1, is 8. And so automatically I can write it as a fraction, so it's included as a rational number. Speaking of fractions, well, fractions are in this category too as rational numbers. They can be positive or they can be negative. And so I could have like 3/5 or I could have -1/4. Positive or negative fractions are included under rational numbers because they are already written as a fraction, and so they fit the definition. Now, fractions are also included in what we call mixed numbers. Mixed numbers have a fraction in them, but they also have a whole number attached. And so mixed numbers are under the category of rational numbers because, they have two pieces that fit this category, a whole number and a fraction part. Now, fractions can be changed into decimals and decimals back into fractions. And so decimals are included under this category because we can change them into fractions. For instance, if I take 0.75, I can change it into the fraction of 3/4. And you do not need to know how to change them into a fraction yet. I just want you to know that this type of decimal, which is called a terminating decimal, it stops. That means this one stopped in the hundredths place, and it does not continue on. And so because it stops, it is in the category as a rational number because it can be written as a fraction. The other category of decimal is a repeating decimal. And this repeating decimal repeats like a pattern. So this symbol right here is called a repetin sign. And it always shows us what is being repeated. In this case, it's repeating a 3. And so it too can be written as a fraction. 1/3 is how we would write 0.333333. Okay, so let's look at a few more examples of rational numbers. The next one is integers. And integers, we will learn more about these as the year progresses. But I just want you to know that an integer, it just looks like a counting number. It looks like a whole number, but it can also have a negative on the outside. Okay, and so it is a whole number, but it's also the opposite of a whole number. So like 3, +3, and -3 are called integers. And they too can be written as fractions. Powers. Powers are rational numbers because they too can be written as whole numbers. 2 to the 3rd power is 8. And we will be working with powers actually in the next few targets. So you will learn how to get 8 out of this expression. And we'll talk about what an expression is as well. But just know that all powers, anything that looks like this, is considered a rational number. Percents. Percents are rational numbers because a percent is out of 100. And so I can put 100 underneath it, and like right away it fits in this category now because it can be written as a fraction. And the last one is called a square root. And square roots have this symbol in it. And what I don't expect you to be able to find the square root of something, but I want you to know that some square roots, like square root of 16, so if I take my calculator and I use the square root button and put 16 in and hit equals, notice my answer. My answer is a whole number. And so because it is a whole number, it equals a whole number, it's under this category of rational numbers. So these are some examples of rational numbers. Now, on the other side, under real numbers, we have what we call irrational numbers. Now those you have also worked with, and I'll give you an example. Irrational numbers are numbers that can't be written as a fraction. For instance, how many of you remember pi from the last couple years, and you worked with this to find circumference of a circle or the area of a circle? And many of you use just 3.14, but it is a decimal that actually goes on infinitely, and there's no pattern at all. There's no repeating pattern. So it cannot be written as a fraction. And so it is included under this category as an irrational number. Here's another example of a decimal that just continues with no pattern. This is an irrational number. This square root, if I put it in the calculator, look what happens. I get square root of 7, and look what happens. I get numbers, no pattern, and it goes on infinitely. This is actually the furthest my calculator will go. So if I had a calculator that went on further, it actually would show me more digits because this does go on infinitely. And so these are some examples of irrational numbers. So today what you're going to be doing is putting them in different categories. Okay, so you need to determine which category would these numbers be in. Are they rational numbers or are they irrational numbers? For instance, 7. Which category would 7 be in? You are absolutely right. It is a rational number because it's a whole number. How about 0.345? Yes, it's a terminating decimal, so it's in the rational category. How about 3/5? It is already a fraction, so it is in the rational category. How about 0.813789, etc., etc., etc.? Yes, it is irrational. There's no pattern. -10. Which category? Yes, it's an integer, and it's in the rational category. How about square root of 4? Now, if you put it in the calculator, this is what you get. 2. Which category would that fall under? Yes, it's a rational number. How about square root 11? If I put it in the calculator, this is what I get. Yeah, it's irrational because this decimal has no pattern and it goes on forever. How about 2 7/8? Yes, it's a mixed number, and I'm sorry I lost the numerator. 2 7/8 is in the rational category. Nice job. Now, at the end of every movie, you will find this exit ticket. And what this means is that you need to complete the problems for the following day. And so this will be your ticket into class. And so these 4 problems, what I would like for you to do is determine if they are rational or irrational. And also determine why. Why are they in those categories? Well, thank you so much for joining me at Carleton's Math Corner, and I look forward to meeting with you again to learn a new concept.